Okay, hi fourth graders. This is Mr. Steinberg. I wanted to see if I could show you, for anybody that might be struggling with the idea of creating equivalent fractions, and the idea behind them. I think I did a really poor job in a previous tutorial, and then I know in our live lesson this week um, wasn't good at all. So I wanted to see if we could maybe come back to these examples here and see if I could show you both visually and then mathematically how equivalent fractions can be created. Because it's a really important skill. So let me get my little writing tools out here. So first thing, if you can see on the screen here, I've got two fraction bars. Um, and you can see one of the fractions is labeled as 2/3 and the other fraction. I have 12 equal parts. I have 12s, but I haven't filled any of them in yet. So I'm going to go ahead and do that. But you can see they're lined up right on top of each other. I'll choose a different color here. I have purple in this one, so I'll go, oh, I don't know, red for the second one. So you can see there's 2 out of 3 here. There's three total parts. Two of them are filled in. So the question would be, how many twelfths would it take in order to be equal to have the same amount as 2/3? So what you do is you just go ahead and start filling them in until they're the same amount. So you have 1/12, 2, 3, 4, 5, 6, 7, 8. So if I fill in 8 out of the 12, it's the same value, it's the same length, it's the same amount as 2/3. It's basically the same number. The only difference is there's a different numerator and denominator for each, but they represent the same value or the same amount. As some of you could probably tell as I was filling this in, if I go back and undo these 4 here, after I did the first 4, you can probably tell that I needed 4 more, another section of 4 to complete the making it equivalent. And the reason that number is important, you'll see mathematically in just a second here. So if I get my little tool out here and make sure I pick a color that we can see. So we've got 1 equal part, 2 out of 3 right there, and here we have 1, and 3, 4, 5, 6, 7, and 8. There you go. So 2 out of 3, 8 out of 12. Now, again, this is the way you can look at it visually. But what if you were somebody that just liked doing the math, right? You were somebody that you like using multiplication or division, and you don't like using fraction bars, and you just like, Mr. Steinberg, I want to make equivalent fractions. So how do I do that? So what you can do mathematically is you can take the first fraction, which is what, 2/3, and you want to set it equal. You want to make it equal to 8 out of 12. So if you remember, when I was filling in the squares for the 12s, I went 1, 2, 3, 4, and then you notice it was going to take 4 more, 1, 2, 3, 4. So what you do is you find a number that you can multiply on the top and the bottom, but that number has to be the same. So for example, if I want to go from 2 all the way to 8, I can multiply 2 times 4. But if I want the fraction to stay equivalent or equal, I have to take that same number and multiply it by the number in the denominator. And 3 times 4 is 12, and we know that both of those are true. But I think what's lost on a lot of people is this part right here. Let me get a different color. If you look at what I multiplied here, some of you get this and some of you don't, and that's okay. It's the idea of multiplying the same number on the top and the bottom. And it's not just doing that, but it's, why is that okay? Why are we allowed to do that? And it all comes back to when you were learning multiplication. Like if you took the number 5 and you multiply the number 5 times 1, you would get the number 5. If you took the number 9 and you multiply 9 times 1, you would get 9. But when you're working with fractions, fractions normally, fraction itself tells you that it's not a whole number. But there is a special feature or a special characteristic of fractions that says if the number on the top is the same as the number on the bottom, well, that equals one whole. So 4 over 4, 4 out of 4 is the same thing as 1. And remember, anytime you multiply something times 1, then the number doesn't change. You see up here, I multiplied 5 times 1, and I got 5. 9 times 1, I got 9. Well, over here, I multiplied 2/3 times 4 out of 4, but 4 out of 4 is the same thing as 1. So 2/3 is the same as 8/12. And you can see that here. You can see we multiplied 2 out of 3 by 4 out of 4, and we got 8 out of 12, and we're saying that they're the same. And it's true because if you come over here, oh no, I don't want to do that. I wanted this. If you come over here and you erase all this so I can move the fraction bars. And let's say I wanted to grab the old fraction bars here. If I place them on top of each other, you can see they're exactly the same. They're the same size. I can do the same thing right here. And remember, it all comes down to the idea that what we're doing is we're multiplying times 1 or 1 whole. And that's why it's okay to use the same number on the top and the same number on the bottom, because it's 1 whole. So again, even though the denominator will change and then the numerator will change and the denominator will change, it's still the same. It's an equivalent fraction. It's the same amount. Fraction looks different, but it's the same. All right, so let's move forward. Let's look at a different example. Let me find the best way to erase all this. I think it was this, right? Clear drawing, yes. Oh, I want to get rid of this one too. Hold on one second. I think I have to trash it right there. Okay. Let's use circles. Let's take, let's say a denominator of, I don't know, 3. How about 4? Say, okay, there's a nice, make a nice large circle right there. And we'll add another circle and we'll say, 16. And then we'll make it a little bit bigger. Oop, oh, that's too big. Oh, that's too much. There we go. Okay. So we have one, let's call it a pizza, right? We can call it a pizza if you want to. We've got one pizza right here where there's 4 total slices and one right here where there's 16 total slices. Now the 16 slices, that's kind of a parent trick. Like if if there's a lot of kids around and you want to make it seem like there's a lot more pizza than there really is, so people don't worry about getting their fair share, you just cut it into more slices. But no matter how many slices you cut it into, it doesn't change the amount of pizza, it just changes how many slices or equal parts there are. So if I were to, let's say pizza is usually this color. Sometimes we use this color. Let's say I colored 1 out of those 4, and then I want to make an equivalent number. I want to shade in an equivalent number of slices so that it's the same as the 1 out of 4. So what I can do is I can start here. There's 1 out of 16, 2 out of 16, 3 out of 16, and 4. So here, hopefully you can see that this amount, this 1/4 of this pizza is the same thing. It's the same amount as this 4/16 out of this pizza, right? We all started with 1 whole pizza. This pizza we broke into 4 parts. This one we broke into 16 parts. This one we colored in 1 of those 4, and this one we colored in 4 of those 16. So let's see mathematically if that's true. Let's see what that looks like. if I have 1 out of 4 and I want to make it equal to 4 parts out of 16 parts, I can do some multiplication. And I can say, well, if I want to go from 1 to 4, I can multiply 1 times 4. And if I want to go from 4 to 16, I can multiply 4 times 4. And that's true. So you can see that visually, like with our fraction circles and our multiplication, that yes, these are equivalent fractions. And remember, we're allowed to do this because why? Because the fraction that we multiplied by, 4 over 4, it represents one whole. And whenever you multiply a number times 1, right, this represents one whole, or 1. If you multiply a number times 1, you get that number. But with fractions, when you multiply by 1 or one whole, you get a different fraction, but it's still equal to the first fraction. So this one is equal to this fraction right there. So I'm going to stop here. I'm going to create another short one where we go opposite, where we use division to show the same ideas.